In the vast darkness of space, there exists something that defies our understanding. Galaxies that glow an intense emerald green. These mysterious objects, known as Green Pea Galaxies, pack more star-forming power than our entire Milky Way into a space roughly the size of a large city in cosmic terms. Despite being around 100 times smaller than our galaxy, these cosmic oddities are churning out stars at a rate that seems to violate the laws of physics. To put this in perspective, imagine a factory the size of Manhattan producing more goods than all the factories in North America combined. That's the kind of efficiency we're seeing in these remarkable galaxies. But perhaps the most fascinating part of this story is how these galaxies were discovered. It wasn't through massive telescopes or sophisticated algorithms. They were first spotted by ordinary people, citizen scientists participating in an online project called Galaxy Zoo. These volunteers were looking through thousands of galaxy images when they started noticing unusual objects that looked like tiny green peas. What started as a curious observation by amateur astronomers quickly caught the attention of professional scientists, leading to one of the most significant astronomical discoveries of recent years. When astronomers first studied these objects in detail, they were completely baffled. Nothing in their existing models could explain what they were seeing. These galaxies weren't just unusual in appearance. Their entire existence seemed to challenge our fundamental understanding of how galaxies form and evolve. Green Pea Galaxies are literally breaking all the rules of galaxy behavior that we thought we knew. And as we're about to discover, that's just the beginning of their strange story. To truly understand what makes Green Pea Galaxies so extraordinary, we need to venture inside these cosmic furnaces where conditions defy imagination. At their core, these galaxies maintain temperatures exceeding 50,000 degrees Celsius. That's 10 times hotter than the surface of our sun. But what creates their distinctive emerald color? The answer lies in one of the most abundant elements in the universe: oxygen. When oxygen gets superheated to these extreme temperatures, it becomes ionized, losing its electrons and emitting an intense green light. It's like a cosmic neon sign, broadcasting the incredible conditions within. This process requires such intense energy that we rarely see it on this scale anywhere else in the universe. The fact that entire galaxies are glowing this way tells us something extraordinary is happening. But the real mystery lies in their star formation rates. These galaxies are creating new stars at a pace that should be physically impossible. In a space smaller than most galaxies, they're producing stars up to 100 times faster than the Milky Way. It's as if they've found a way to bypass the normal limits of physics. According to our current understanding of star formation, this shouldn't be possible. The intense radiation from all these new stars should actually prevent more stars from forming. Think of it like trying to light a match in a hurricane. The very conditions these galaxies create should make it impossible for them to continue their frenzied star formation. Yet somehow, they persist. We thought we understood the speed limit for star formation in galaxies. Green peas aren't just breaking this speed limit, they're shattering it. These galaxies are converting gas into stars with an efficiency that surpasses anything we've seen before. It's as if they've found a cosmic shortcut we never knew existed. The intense star formation should create enough pressure to blow these small galaxies apart. Their very existence challenges our understanding of galactic stability. Yet these cosmic rebels remain intact, somehow maintaining their furious pace of star formation while holding themselves together. They're not just breaking the rules of physics, they're rewriting them. While studying these unusual green galaxies, astronomers made an incredible realization. They might be living fossils from the dawn of time. These compact powerhouses share striking similarities with the very first galaxies that formed after the Big Bang. They're giving us an unprecedented window into the early universe. 13 billion years ago, the universe was a very different place. It was dark, filled with hydrogen and helium, waiting for the first stars to ignite. The first galaxies were crucial in transforming this dark cosmos into the light-filled universe we see today. And that's where our story gets really interesting. When scientists compared the light signatures of Green Pea galaxies with theoretical models of the first galaxies, they found remarkable matches. The same intense star formation, the same compact size, even similar chemical compositions. And speaking of subscribing, just like how these galaxies transformed the ancient universe, you can transform your understanding of space by subscribing to our channel. We're constantly exploring mind-bending cosmic mysteries like this one. These modern green peas are essentially showing us what the universe's first light show looked like. They're pristine laboratories for studying how galaxies behaved when the universe was in its infancy. But how have these ancient-style galaxies survived into the modern era? The answer lies in their isolation. Unlike most galaxies, which have merged and evolved over billions of years, green peas have remained remarkably isolated. They're like cosmic time capsules, preserving conditions from the early universe. Their chemical makeup tells the story. They're primarily composed of hydrogen and helium, with very few heavy elements. This matches what we'd expect from galaxies formed shortly after the Big Bang. By studying green pea galaxies today, we're literally watching how the first galaxies transformed the universe, played out in real time before our eyes. These cosmic time machines are revolutionizing our understanding of how the first stars and galaxies formed, and how they turned the dark, early universe into the brilliant cosmos we see today. Green pea galaxies are hiding another extraordinary secret. They're leaking massive amounts of radiation into space, and this discovery might solve one of astronomy's greatest mysteries. Recent observations have revealed that these galaxies are hemorrhaging high-energy radiation, particularly ultraviolet light, at unprecedented rates, almost like cosmic lighthouses beaming energy into the darkness. But what makes this leak so significant? To understand, we need to look at one of the universe's most perplexing transformations. Shortly after the Big Bang, the universe was filled with a thick fog of hydrogen gas, making it completely opaque. But something changed, something powerful enough to clear this cosmic fog. This process, called cosmic reionization, required immense amounts of energy to break apart hydrogen atoms, turning the universe from opaque to transparent. But the source of this energy has long been debated. Green pea galaxies might be showing us exactly how this happened. They're leaking up to 50% of their high-energy radiation into space, far more than typical galaxies. Each galaxy acts like a powerful floodlight, ionizing the gas around it. If the first galaxies leaked radiation like these green peas do, they could have cleared the cosmic fog surprisingly quickly. This discovery is revolutionizing our understanding of how the universe became transparent to light. By studying how green peas interact with their surroundings, we're watching a replay of how the universe transformed from a dark, opaque fog into the transparent cosmos we see today. The intense star formation in these galaxies creates tremendous pressure, literally punching holes in their gas envelopes. These holes become escape routes for radiation, turning what should be a catastrophic buildup of pressure into a crucial mechanism for spreading energy through space. The implications of this discovery stretch far beyond these tiny galaxies. They're helping us understand how light itself spread through the early universe, setting the stage for everything we see today. Green pea galaxies aren't just challenging what we know about the cosmos. They're forcing us to completely rewrite our understanding of how the universe works. Astronomers around the world are going back to their drawing boards. Their existing models of galaxy evolution simply cannot explain what we're seeing in these remarkable objects. The star formation rates in green peas should be impossible. The galaxies themselves shouldn't exist. Yet here they are, challenging everything we thought we knew. While most galaxies follow predictable patterns of growth and star formation, green peas seem to operate by their own rules. They're like cosmic rebels, defying our carefully constructed theories of galactic behavior. The implications ripple through every branch of astronomy. From our theories about star formation to our models of the early universe, these tiny galaxies are having an outsized impact on our cosmic understanding. There must be unknown processes at work inside these galaxies, forces or mechanisms we haven't yet discovered that allow them to achieve such extraordinary feats. Some astronomers suggest we might be seeing new physics in action. Something in these galaxies is accelerating star formation beyond what we thought possible, and finding out what could revolutionize our understanding of the cosmos. As we look to the future, Green Pea Galaxies stand as a humbling reminder that the universe still has plenty of surprises in store for us. New telescopes and technologies are being deployed to study these fascinating objects. Each observation brings new questions, new mysteries, and new opportunities to understand our cosmic origins. These strange green galaxies are more than just cosmic curiosities. They're windows into fundamental processes that shaped our universe, and they're showing us just how much we still have to learn. From their impossible star formation rates to their role in transforming the early universe, Green Pea Galaxies continue to surprise and inspire us. They remind us that in science, our greatest discoveries often come from the most unexpected places. Thanks for joining us on this exploration of one of astronomy's most fascinating mysteries. If you enjoyed this journey through the cosmos, don't forget to like and subscribe for more stories from our amazing universe. Until next time, keep looking up and wondering.